Welcome to this video on the topic of fun and factorization. Chapter A, Factorization. In this lesson, you'll learn how to factorize algebraic expressions by common factors. Algebraic factorization is the reverse process of expansion, where in the past you've been given expressions containing brackets and told to expand outwards. In this instance, you're going to be given expressions like the one shown over here and told to rewrite it in terms of brackets. Now, this is a useful skill to know how to do because when you're solving equations in the future, the only way you'll be able to solve certain equations is by using factorization. So let's have a look at how we can do it. Example 1, 18r plus 45. What we want to do is we want to rewrite this in its most factorized form. Now, the steps we're going to employ here is firstly, we're going to find the highest common factor between the coefficients of 18 and 45. We're then going to rewrite this expression in terms of its highest common factor, and finally, we're going to factorize all of that out. So to do this, we first need to find the highest common factor. Now, the way in which I typically find the highest common factor is using something called a factor tree. If you're unsure about how to use factor trees, I'll have a link up here on the document you can use. Otherwise, let's have a look at how this can be done. We need a factor tree for the number 18 and we need another one for the number 45. Now, the factor tree algorithm I'm going to use is something called a prime factor tree. This is done by starting off by trying to divide the number of interests by the lowest prime, and then as each prime fails, we work our way up until finally we have a prime number left over. So, putting that to practice, the question is, can I divide 18 by 2 and get a whole number result? The answer is yes, I get 2 and 9. Next, can I divide 9 by 2 and get a whole number result? The answer is no, I get 4.5. So I move to the next prime, which is 3. Can I divide 9 by 3? The answer is yes, I can. So I get 3 left over. And therefore, I've found all of my factors. Washing and repeating. 45. Can I divide that by 2 and get a whole number result? No, so I move to the next prime number across. 3. Can I divide 45 by 3? The answer is yes, I get 15. Next question, can I divide 15 by 3? The answer is yes, I can. I get 5 left over. And thus I find all of my prime factors because 5 is prime. Next, what I'm going to do is I'm going to play a game of matchy-matchy across my trees. Every time I see something in common, I match them up. I see 2 here, but I don't see 2 here, so I ignore the 2 here. I see 3 here, and I see 3 here, so I play matchy-matchy. I see 3, I see 3, I play matchy-matchy. And then I'm out of numbers here, so I stop. Next, all the numbers that I matched up, I'm going to multiply them together. 3 by 3 gives me 9, and therefore 9 is my highest common factor. Now that I know my highest common factor, I can commence factorization on the left here. I start off and I write 9. I ask what happens when I divide 18 by 9? Well, I can say I have 2 left over, and I put the R down. Next, 9. What happens when I divide 45 by 9? I get 5 left over. Okay, time to factorize. What do I have in common between both terms? I've got 9. What don't I have in common? Well, I don't have a 2r and I don't have a 5. So I'm going to have 9, 2r plus 5. This is what I didn't have in common. This is what I did have in common. So therefore, this is my factorized form. So in summary, what we do to factorize an expression is we first find the highest common factor between the coefficients. We then divide all the coefficients by the HCF, and we then, what we have in common, we pull it outside, and whatever we have not in common, we throw it in brackets on the inside. Let's do this again. 40W take 20. I start off by drawing my factor trees. I then find the highest common factor. Now in this instance, notice that I filled up all of the factor tree on the right here. Rather than picking the highest common factor from this, I can simply go, I have 20 here and 20 appears over here. So therefore, 20 is the HCF. Next, I put down 20, which is my highest common factor, and then I divide 40 by 20. That's going to give me 2W. Minus 20. What happens if I divide 20 by 20? I get 1. Next step, I have a look and I can see that I've got a negative here which I don't really like. So rather what I'll do is I'll turn that into a positive and stick the negative on the -1. So when I divided here, I said 20 divided by 20, which gave me -1 left over. After which, I go 20 and 20 is what I have in common. 2W and -1 is what I don't have in common. So I'm going to get 20 on the outside, 2W on the inside, take 1. Therefore arriving at my most factorized form. So again, you find your highest common factor using the factor trees, you then divide your coefficients by the HCF, and then you pull out what's in common, you leave behind in the brackets what was not common. Okay, let's have a look at how we can extend this knowledge. A zero is a value of an unknown that when substituted into an expression causes the expression to equal 0. So suppose if we have the expression x multiplied by x take 1 and we want to make this expression here equal 0, there's two ways we can go about this. There's an x on the outside, and if we let that x over here equal 0, then the whole thing becomes 0. So 1 0 is at 0. Next, the x on the inside, you ask yourself, what do I need to set this to make everything in here equal 0? Well, if you've got something take 1, to make it equal 0, you'd say 1 take 1, so let x equal 1. That will cause this side to equal 0. So therefore you've got zeros at 0 and 1. Okay, using this knowledge, we're going to combine it with what we were doing before. Example 2. Factorizing trickier algebraic expressions. So in this instance we have 18p squared take 15p. What we're going to do is we're going to first factorize this and then we'll find the zeros. To do this I need to find the highest common factor. I'll do that by my factor trees. And as can be seen, my HCF is 3. So factorizing for this, 18 divided by 3 is going to be 6p squared, minus 15 divided by 3 is 5p on the outside. And again, I don't like this minus here, so I'm going to turn it into plus, and in doing so, I'll make that 5 a -5. Next, you can see that we've got common p's between these two terms. Because they're common, we can actually factorize for that. We pick the smaller one and we say that's our benchmark, and then we turn this larger one such that we pull out a factor of the smaller one. So we've got p over here, we'll just write this as p. Next, we look at what's common, 3 and p, 3 and p. What wasn't? 6 and p minus 5. Rewriting this, 3p is what we had in common. What we didn't have, we'll put in brackets, 6p take 5. Thus arriving at our most factorized form. Next, we need to state the zeros. If we have a look at over here, we've got a p on the outside. If we set this to 0, then it will make 3 become a 0, and then anything multiplied by 0 is 0, so first 0 is at 0. Next one. This one's a little bit trickier. You have to ask yourself, what value can I set p to such that the inside of the bracket equals 0? Well, if you look at it, p is multiplied by a 6. So what you need to do is you need to reverse that multiplication by 6, and then you need to turn whatever this whole thing was into a 5. So we want to turn it into a 5. We want to reverse a 6. So we say it's going to be p equals 5 over 6. A little bit confusing, but with a bit of practice, it will become clearer. So these are our zeros. Okay, next one, minus 15d plus 20d squared. We're going to factorize this again by firstly finding the highest common factor. I can see that the highest common factor is 5 in this instance. So factorizing that out, pull out the 5, leave behind the 3 minus 3d. Pull out the 5, leave behind the 2 by 2, which is 4d squared. That should be outside. Next we look at the variables. We have single d, d squared. That means we've got at least one d across both of the terms. So we break that d squared into d, d. Thus we have 5d, 5d in common, minus 3, 4d not in common. Writing this out, 5d is common, minus 3 plus 4d is not common, hence arriving at the most factorized form. Now this is fine, this is the most factorized form, but as mathematicians sometimes we like to make a slight tweak to this. Notice that you've got the negative on the left hand side inside the bracket. We typically don't like to have negatives like this. Rather, what we prefer to do is we prefer to write it such that the positive numbers are always on the far left. So this can be rewritten as 5d multiplied by 4d, take 3. This also makes it easy to find the zeros. Now, doing that, there's going to be zeros at. Now we can see that there's a d on the outside, so if we set that d to 0, then everything becomes 0. And similarly, there's a d on the inside. You are going to multiply this d by 4, and then you have to cancel out this minus 3. So first thing we want is we want the d to become a 3, and we want to cancel out the 4. So d is going to be 3 over 4. Okay, let's have a look at something a little trickier. Example 3, factorize. We arrive at some expressions that look harder but are actually the same as what we've already been doing. We've got 12z to the power of 6 plus 30z to the power of 4. We want to factorize this. Now again, we'll factorize this by finding the highest common factor between 12 and 30. Using the factor tree, we see the factors are 2, 2 and 3, 2, 2, 3 and 5. What's common? 2's and 3's. So therefore the HCF is going to be 2 by 3, which is 6. Taking out the highest common factor, 12 divided by 6 is 2. We leave behind z squared, or z to the 6, plus 30 divided by 6 is 5, z4. You can see that there's a z4 and a z6. z4 is smaller, so we can rewrite the z6 as z4 multiplied by z2, because it's still equal to z6. And then what's common? Well, 6, z4, 6, z4. What's not common? 2, z2, 5. Factorizing this out, 6, z4 is what we had in common. 2z squared is what we didn't, as well as 5. Thus arriving at our most factorized form, 6z to the power of 4 times 2z squared plus 5. Okay, final one, B. 21q cubed minus 35q to the power of 7. Drawing our factor trees. What do we have in common? 7's. So I've got a highest common factor of 7. Taking this into account, 21 divided by 7 is 3. Q cubed minus 35 divided by 7 is 5. Q 7. I've got Q's across both of my terms. The smallest one is to the power of 3, so I break the 7 into Q to the 3, Q to the 4. and then I look at what's common. 7q cubed, 7q cubed. Again, I've got a minus here, so I'll change that to a plus and give the minus to the 5. And then looking at uncommon, 3 minus 5 q to the 4. Writing this down, 7q to the 3. 3, take 5q to the 4, which brings us to our most factorized form. So in summary, what we set out to learn in this lesson was how we could factorize expressions using common factors. The way in which we did this was, firstly, we found the highest common factor between our coefficients. We then looked at the highest combination of variables. We broke it down into the lowest one and then split it, and then we simply take out what's common across both terms, and then inside the brackets we put what we left behind.